Stochastic matrices are used in the field of probability and statistics. A stochastic matrix is a square matrix whose rows are probability vectors. Computers run simulations based on stochastic matrices to model events ranging from gambling through weather forecasting to quantum mechanics. A stochastic process is also known as a random process. Now we will show you an example of how a search engine ranks 4 different website pages using the stochastic process. You will understand the reasoning behind the order of the results when you use Google, for example.
Okay, here is an example about the 4 website A, B, C, D, and now I will show you how the 4 website links each other. Like for the website A, we can see there is 3 lines from A to B and A to C and A to D. Now it's 3 lines. That means the website A links to the 3 pages. And do the same thing for B. The website B has the B links to A, so now it's 1 line. That means B only have 1 line to links to A, and we do the same thing for C and D. Okay, so for this picture, we can make a probability of the matrix. The A, B, C, and D. For the A to A, we can say, for the A to A is 0 and B to B is 0. So this phone number is 0. And for A to B, we can say that A has 3 lines outside, so each line is 1/3, because the sum of the 3 lines should be 1. And for the B, we only have 1 line outside, so the sum is 1. The line of B to A is 1. And to do the same thing, C has 2 lines out, so each of the line is 1/2, and D has 1, 2, so it's 1/2 also. Now we can put the number on the matrix. The A to B is 1/3, and the A to C is 1/3 also, and the A to D is 1/3. For the B to A is 1. So B only have 1 line out, so other things is this 2 number is 0.
Now that we have our probability matrix P, we're going to put that into a Markov chain and continue that chain until xk plus 1 equals xk. So to start off, we have our probability matrix, but for our x naughts, we will be using A, B, C, D to represent the websites. But in order to calculate and get actual numbers, we're going to turn those into fractions of the number of websites we have. So that will be 1/4 each, which will be 0.25. So once you solve this, you'll get the result 0.37, 0.08, 0.33, 0.20. And since this does not equal that, we'll continue and do our second step, where we plug in our x1 here, 0.37, 0.08, 0.33, 0.20, to equal our x2, which will now be 0.43, 0.12, 0.27, and 0.16. And as you go along, you see that you'll have to do until you get to x to the 8 to verify your x to the 7 number. So here we would have 0.38, 0.12, 0.29, and 0.19. And when you solve this, you'll end up getting the same numbers here. This is called our equilibrium value, so that's where we stop the Markov chain. So we take this value and have it equal the websites that we had before, A, B, C, D. And since we have these equaling these now, we can finally rank the pages by the value of those numbers from highest to lowest. So the resulting page rank would be A, C, D, and B. And that's how a Google search engine works.